Hello dear student of 12th standard, your exam is nearby and you feel that physics is a very tough subject. But it's not like that. It is very interesting and very easy subject. So today we are going to see first chapter, rotational motion, and in that circular motion. Okay? So you know what is circular motion? The motion of the particle along the circumference of a circle is called as circular motion. Means you know that what is circle? In order to draw a circle, you need a fixed point and a fixed distance, and then only you can draw a circle. So circle is a locus of point drawn with fixed center and a fixed distance. Now when the particle will move along this circumference of this circle, along the circular path, then this particle is said to be in the circular motion. Okay? So now suppose here is one particle, say, okay, at A position, and this is the fixed distance from the center. After some time, this particle say come to this point B. Okay, what does it do? It makes some angle theta. Suppose after some time, this particle comes to position C, position D, likewise. And every time, as it will move away from the starting point, angle will go on increasing. So what you see, when the particle move along the circular path, it makes an angle at the center. There is angular displacement. It makes an angle at the center, and therefore we also call this circular motion of the particle as angular motion. So what we also call this chapter, circular motion, as angular motion. Angular motion. Theta, angular displacement. Now see, when this particle comes from A to B, this displacement from A to B or from B to C is called as linear displacement. What it is called? Linear displacement. Now linear displacement, you know the meaning of linear displacement? When a particle moves along a line, straight line, और जब line बनता है ना तो उसे हम क्या बोलेंगे? Linear displacement. यहाँ पे हमें सर्कुलर मोशन में पार्टिकल क्यों है? क्योंकि वो क्या कर रहा है कि एक आर्क, एक सर्कमफरेंस पे वो चल रहा है, तो जो आर्क बन रहा है, सर्कुलर पाथ बन रहा है, इसलिए हम उसे क्या कह रहे हैं? सर्कुलर मोशन. और जब लाइन में चलता है तो सब लीनियर मोशन कहते हैं. और यदि आप लाइन का ज्योमेट्रिकल डिफिनेशन आप जानो तो व्हाट इज लाइन? It is the shortest distance between the 2 points on a curve. है ना? ये definition है line का. So if the displacement is very small, so along this path, this displacement is a linear displacement. And here at center, what is happening? The displacement is angular displacement. So let us denote this linear displacement by letter S. We'll denote this linear displacement by letter S. So there must be some relation between the linear displacement and angular displacement. Okay. So what is the relation? Let's see. Now see here, in mathematics you have learned that angle subtended at the center is equal to length of arc upon radius of the circle. Length of arc upon radius of the circle. Now if the displacement is very small, that is the linear displacement, so you call this theta is equal to linear displacement, that is S upon R. So that is linear displacement S is equal to R into theta. So see here, linear displacement, we denote it by S, we have already written. Angular displacement is equal to theta. And what is the relation we have got? S is equal to R theta, or you can say that theta is equal to S upon R. This is the relation that we have got. Now, after seeing all these things, if I ask you how you are going to define angular displacement, very simple, you can tell me what is the angular displacement definition? Angle subtended by the particle at the center while performing the circular motion is called as angular displacement. An angle subtended by the particle at the center while performing circular motion or angular motion is called as angular displacement. Now, what is the SI unit? What is the SI unit of angular displacement then? So we know that we measure SI unit of to measure angle is radian. So SI unit is equal to what? Radian. Now up to now you have measured angle in degree, means you have drawn the angle 30 degree, 45 degree, 60 degree. So you must know the relation between degree and radian. So what is the relation? 1 degree, angle in degree is equal to pi by 180 radian. So when particle moves around the circular path, always the angles goes on changing, pi by 6, pi by 4, pi, 2 pi, like this. And the maximum angle that the particle will subtend while performing the circular motion at the center will be what? Means starting point A, and again if it comes at A, then the whole circular path is covered, and the angle is what? 2 pi radian. So maximum angle subtended by a particle while performing the circular motion is 2 pi radian. Remember, this question may be asked in the CET, that what is the maximum angle subtended by a particle while performing a circular motion at the center? So answer is what? 2 pi radian. What is the answer? 2 pi radian. Now you see this is a circle, the particle is moving. Now when this particle is here, suppose here, what the direction of this particle? Linear direction, here linear direction, here linear direction. But you know that displacement is a vector quantity. Now displacement is a vector quantity, then it must have direction. Angular velocity must have the direction, because what is the vector quantity? A physical quantity which need both magnitude and direction to explain is a vector quantity. So now angular displacement, whatever angular velocity, all are these are the vector quantity, and we need to tell the direction of this angular displacement. Remember, this is the direction of the particle which is performing the circular motion, and here you see that it is a linear direction. And angular displacement क्या होगा? The direction will be along the axis. This is the axis of this angular disc, circular disc. This is the axis, and the displacement, because see the angle is subtended at the center, and this is the direction of the angular displacement will be along the axis of that circle. Now here, suppose this is the axis. Now whether the direction of the angular displacement will be outward or inward, who is going to decide? How we are going to decide? So there is one rule called as right hand thumb rule or screw rule. So what this right hand thumb rule explains, and it says that when a particle is performing circular motion in clockwise direction, see here, and if this my finger, if my this finger is denoting the motion of the particle, then this thumb denotes the direction of the angular displacement. Okay, so you can see here, if I do like this, then you can see that my thumb is pointing inward. So when the particle is performing the circular motion in clockwise direction, then the angular displacement will be on the axis, will be pointing inward, it will be going inside. Screw, you have seen the screw. Now see the practical application of application. See, this is the screw that you must know. You must be knowing the screw. You must have used also. So this is the screw. So what you do, if you want to insert a screw, if you want to screw it with the help of that screwdriver, what you do, you rotate like this in clockwise, and what happens? The screw go inside. Means angular displacement along the axis. So inside, when the direction is along the axis and it is going inside, we do not like this, and when it is coming outside, we do not like this. And when it will come outside, now when it is moving in anti-clockwise direction, so now with the help of my hand I cannot do like this. Okay, so what I will do? I will do like this, and this, if this finger denotes the motion of the particle along the circular path, then this will denote, my thumb will denote the direction of the angular displacement. You can see that which is pointing outward. So I hope you understood the direction of angular displacement. Okay, and so here I have explained you what is circular motion. Motion of the particle along the circumference of a circle is called as circular motion. What is angular displacement? The angle subtended by the particle at the center while performing the circular motion is called as angular displacement. It is denoted by theta, and the circular motion is also called as angular motion. Why? That reason I have told you. Then we have seen relation between the linear displacement and angular displacement, that is S is equal to R theta or theta is equal to S upon R. We have seen SI unit to measure angular displacement, and it is radian. We have seen relation between degree in radian. 1 degree is equal to pi by 180 radian. Means if you want to convert degree into radian, multiply by pi by 180. For example, 30 degree can be written in radian 30. So I will write here 30 into pi by 180. So you get 30 degree is equal to pi by 6 radian. So I hope you have understood. Okay. So tomorrow in the next video I will be explaining you angular velocity. Don't miss it. It's a very important lecture, and I hope this part, angular displacement, you have understood. Thank you. Till then, bye bye.